Hi everyone, my name is Romain Michon and I'm a researcher at GRAME. During this 1-hour workshop, I will teach you how to build your own gramophone. That is the gramophone. And I will show you how to use it to make your own musical instruments. Now, before we get our hands dirty and actually start building our own gramophone, we need to answer a simple question. What is the gramophone? The gramophone is a mobile standalone musical instrument programmable with Faust. Sound is produced by a speaker and it is completely battery powered. The battery can last about 24 hours while it's on. It hosts various sensors that can be used to control the generated sound. You will find motion sensors, such as an accelerometer and a gyroscope, multiple rotary potentiometers and light sensors, which is a photoresistor, basically a microphone and a button. Yes, a button. They can all be mapped to sound synthesis parameters, as you just saw, directly from the Faust code. And that's something that we'll see later in this presentation, how that works. Other elements of the gramophone allow you to turn it on and off, to cycle between different Faust programs, to plug headphones, or to wire it to a mixer. The gramophone can be charged using a micro USB cable, which you can see here. The same cable can be used to connect the gramophone to a computer to program it. Now, some of you might be wondering, why the heck would you want to make this thing? So the first question we will answer here is why the gramophone? The gramophone has been created as part of the Amsterdam GRAME project. Amsterdam GRAME is a STEAM project bringing together services and resources for the educational community. The main goal of Amsterdam GRAME is to make abstract scientific concepts more tangible and concrete through musical creation and computer programming. Scientific concepts are explored through the programming of the gramophone thanks to the Faust programming language. Students eventually work towards a musical project with their teacher. And over 160 gramophones have been built and are already touring in the middle schools of the Auvergne-Rhône-Alpes region in France. So that is why we're making the gramophones. Besides that, they're fun to play and they can be used to write electronic music pieces. Okay, so let's now get our hands dirty and learn how to make a gramophone from scratch. These instructions can also be found on the Amsterdam GRAME website at the URL below. We will assume in this tutorial that you know how to solder and that you have some experience with hardware in general. Let's first have a look at the components which are needed to build the gramophone. By the way, feel free to get back to this list whenever is appropriate. You can also find it on the Amsterdam GRAME website at the URL below. First, you will need to acquire the gramophone case. While it cannot be purchased directly, the STL files of the case can be downloaded on the Amsterdam GRAME website and then printed using a 3D printer. If you don't own a 3D printer, which is the case of most people, you can also have them printed online and shipped to you. There are many websites that provide this service. I won't mention all of them here since they vary from one country to another. You will need a Liligo TTGO T audio board, which is the heart and the brain of the gramophone. It is based on an ESP32 microcontroller and it hosts motion sensors and an audio codec. You will need an IMA 3-watt speaker. Make sure you get exactly this speaker model, otherwise it won't fit on the gramophone. Or, by the way, you could just download the source files of the case of the gramophone and adapt it to anything you want. The Gramophone is a completely open source project. So all the sources are available online on the Amsterdam website. You will need a 3.7 volts, 2050 milliamps per hour battery. Make sure you get exactly this model, otherwise it won't fit in the Gramophone. That's just like for the speaker. By the way, we're sorry if we're showing you the links to retailers in Europe, but at least you will be able to get the part reference this way. You will need a small battery connector. There should be one that comes with the LilyGo TTGo T audio. You will need a 3-position switch. This kind of switch should have 6 pins at its bottom. You will need a set of 2 10K rotary linear potentiometers with their corresponding knob. Of course, the color of the knob doesn't really matter here. You will need one large 22 by 7 millimeter washer. You will need one 18 by 6 millimeters washer. You will need 6 7 by 4 millimeters washers. You will need a rotary encoder with an integrated button, 6 10K resistors, 1 photoresistor, 4 YLF TF 2.5 by 10 PZ1 AB SPAC screws, 10 YLF TF 2 by 10 PZ1 AB SPAC screws, 1 250 by 25 by 1.4 millimeter strap, 1 25 millimeter strap buckle. Let's now have a look at the supplies you will need to build the Gramophone. Feel free to get back to this list whenever is appropriate. You can also find it on the Amsterdam website at the URL below. You will need electrical tape, white, red, and black 22 AWG stranded wires, heat shrink sets, solder. You will need 10 wires ribbon cable. Here I'm holding 2 of them next to each other's. 1 female IDC-20 plug. Okay, now let's have a look at the tools needed to build the Gramophone. You will need a small plier. You will need a small wire cutter, a medium-sized plier, 1 8 and 1 10 millimeter wrench, 1 small Phillips screwdriver, 1 pair of tweezers, 1 stripper, 1 dentist tool, 1 heat gun, 1 multimeter, 1 soldering iron. This time, we're ready to build the Gramophone, so let's get our hands dirty. The first thing we need to do is to prepare the components before we install them in the Gramophone. The first one we will take care of is the ribbon cable and the female IDC-20 plug. Cut 2 sections of about 12 centimeters of the ribbon cable. You can use regular scissors for that. Then put the 2 cables next to each other and slide them into the IDC plug. Once they are perfectly aligned, you need to force press the plug. There are special tools for that, and I don't have access to them right now, so I just used a clamp to do this. What's important is that the amount of pressure you apply on the plug is well spread on its surface, so using regular pliers is not a good option here. After you're done with this, you must separate all the individual wires and cut the ones that we won't be using as shown on the picture here. Feel free to pause the video at this point to look at this picture in more details. The next component we need to prepare are the two rotary potentiometers. They usually come with a small strip that needs to be broken using a plier. Just grab it with a plier and pull it. You'll have to do that on both potentiometers. Next, you shall solder the 10K resistor on the left and center pins of the potentiometer as shown on the picture here. We recommend you to pre-solder the pins to facilitate this operation. Make sure you bend the pins 90 degrees before you do that. In fact, you can see on the picture here that pins are bent. That's a very important step. You should cut the legs of the resistors to keep things clean. Put a heat shrink on the resistor. You should, of course, cut it to the right size. Then shrink it using the heat gun. Let's now prepare the encoder. The encoder should have pins on two sides, one with 2 pins and one with 3. Solder 2 10K resistors to the side with 3 pins as shown on the picture. There should be 1 resistor on the left and right pins. The center pin should not be used for now. As for the potentiometers, pre-soldering the pins should make this operation easier. Now solder the 2 resistors together as shown on the picture. You should cut the legs of the resistor to keep things as clean as possible. On the back side of the encoder, solder a wire between the center pin near the resistor and the left pin on the other side. Now that the encoder is ready, solder a 10K resistor to one of the pins of the photoresistor. This type of component doesn't have polarity, so you can pick up any pin you want to do this. You can protect and insulate the pins of the photoresistor using heat shrinks as shown on the picture. This will prevent potential shorts in the gramophone. Solder a 10K resistor to the button. As the photoresistor, the button doesn't have a polarity, so any of the pins can be used for that. We can now prepare the speaker. First, cut 2 wires, one black and one white of about 14 centimeters each, and strip them on both ends. Make sure that you remove a very small section of the insulant on one side because the solder points will have to be very small on that end. We also recommend you to pre-solder the wires at this point. Now solder the black wire to the negative pin of the speaker and the white wire to the positive pin. Make sure that you use the side with the long strip on the speaker. The small solder points on the other side will be carried out later. Let's now prepare the battery. Be careful when manipulating the wires of the battery to not create a short. Lithium batteries can be slightly dangerous in that regard, so let's be careful here. Cut an 8 centimeters long red wire and soldering to the red wire on the battery to extend it. Then make sure to cover the solder joint with a heat shrink. Then solder the battery plug only to the black wire of the battery as shown on the picture. Insulate the solder joint as well as in the previous step. Finally, insulate the yellow wire that we won't be using for this project at all. Okay, we're now ready to prepare the 3-ways switch. Pre-solder the 2 leftmost pins of the top row and the 2 rightmost pins of the bottom row as shown on the picture. Now that all the components are ready, we can start assembling the gramophone. First, mount the first potentiometer as shown on the picture. It should be placed between the square hole and the large circular hole. The pins should be oriented towards the larger end of the case. Make sure it is fastened properly using the 10mm wrench. You can then mount the second potentiometer on the case. Look at the picture to figure out its location. The pins should also be oriented towards the larger end of the case. Make sure it is fastened properly using the 10mm wrench. Let's now mount the encoder. Note that the side with the resistors should be oriented towards the larger end of the gramophone. Make sure it is fastened properly using the 10mm wrench. Again, we can now mount the button on the gramophone case. The orientation of the pins doesn't really matter. In order to mount the switch on the gramophone, we first need to place the 6mm washer on it. You can then place it in the gramophone as shown on the picture. Once you put it through the corresponding hole, put the 7mm washer on the other side and then fasten it to the case with the bolt and the 8mm wrench. Put the photoresistor in the hole highlighted on the case with some kind of ring. You really can't miss it. It should just press fit in it, so you might have to push a bit on the photoresistor to go in its housing. Optionally, you can put some hot glue at the back of the photoresistor inside the gramophone to hold it in place. Now that most of the components are mounted on the case, we can start wiring them. Cut a small section of black stranded wire, strip it and pre-solder it, and then solder it as shown on the picture to the bottom right pin of the switch and to the left pin of the potentiometer right next to it. Do the same by connecting the left pin of the same potentiometer as in the previous step to the center pin of the encoder on the side with the resistors. Continue this chain by connecting the same pin on the encoder as in the previous step to the 10K resistor soldered to the photoresistor. Connect this last point to the left pin of the neighboring potentiometer as shown on the picture. We can now end this chain by connecting the last pin of the previous step to the 10K resistor soldered to the button. As you probably understood it, this wire is for the ground, so let's now bring power to the components using the stranded red wire. Connect the rightmost pin of the potentiometer right next to the encoder to the resistors of the encoder itself. Continue the chain by connecting the resistors of the encoder to the left pin of the photoresistor, which is basically not the one with the 10K resistor soldered to it. It's the other one. Continue the chain by connecting the photoresistor to the rightmost pin of the neighboring potentiometer. Finally, end this chain by connecting the potentiometer from the last step to the pin of the button without a resistor soldered to it. We're now ready to solder the ribbon cable to the gramophone. It will be used to connect the various components of the gramophone to the LilyGo TTGo T-Audio board. Solder the leftmost orange wire to the right pin of the potentiometer next to the encoder. This is basically the ground. Then solder the yellow wire to the left pin of the same potentiometer. This is power. After that, solder the green wire to the center pin of the potentiometer. The next wire on the ribbon cable is the violet one. You should solder it to the right pin of the photoresistor, which is basically the one with the 10K resistor soldered on it. You want to solder the violet wire to the pin itself, not the resistor, of course. The next wire on the ribbon cable is gray. Solder it to the center bottom pin on the switch, right next to the black wire. Then comes the red wire, which should be connected to the center pin of the potentiometer next to the button. The following orange wire should be soldered to the right pin of the encoder on the 10K resistor side. Here is a close view of the encoder so that you don't make a mistake. The following gray wire should connect to the encoder as well, but on the other side than the previous wire. It should be soldered to the pin without another wire soldered to it. The next wire is white, and it should be soldered to the leftmost pin of the encoder on the side with the 10K resistor. Finally, the black wire should be soldered to the pin of the button with a resistor on it, as shown on the picture. We now need to connect the battery to the system. Solder the two red wires coming from the battery to the two remaining pre-soldered pins of the switch. The speaker can now be mounted on the front face of the case using the 4 YLF TF 2.5 by 10 PZ1 AB SPAC screws with the small washers. There is no specific orientation for the speaker. Just put it the way you want. We also recommend you to cover the speaker driver with electrical tape to prevent potential shorts in the system. That's an important step. Actually, don't miss it. Make sure that the black and white wires of the speaker come out on the underside of the gramophone, along with the ribbon cable connector and the battery. On the LilyGo TTGo T-Audio, cut the 2 leftmost and the 2 rightmost pins of the male IDC connector as shown on the picture. You can use a small wire cutter for that. Now spot the future position of the board inside the case. The 2 remaining circular holes on the case should be for the microphone on the board and the jack audio output. Connect the battery to the board as shown on the picture. The battery will go behind the board, so you should take that into account. Connect the female IDC connector of the ribbon cable to the board as shown on the picture. The orientation of the connector matters, of course. Put the board inside the case and fasten it using 2 of the YLF TF 2x10 PZ1 AB SPAC screws. Make sure you put small washers between the screws and the board as shown on the picture. The battery wires should come out as well as the speaker wires. Solder the 2 speaker wires to the board as shown on the picture. The black wire should be connected to the negative pin and the white wire to the positive pin. Put the battery in the case on top of the board and put a thin layer of foam on it so that it is holding in place when we close the case. We can now prepare the strap. Attach the buckle to it by sewing the strap on itself. You could also staple it if you don't know how to sew. Burn the ends of the strap to prevent it from shredding. Install the strap in the back of the case as shown on the picture here. Buckle the strap up and the back of the case should be ready to be mounted on the gramophone. Close the box with the small screws. Mount the speaker grid on the gramophone and fasten it using the remaining small screws. You should respect the orientation on the picture. Finally, yes, finally, put the knobs on the potentiometers and the encoder. Your gramophone is now ready for showtime. Now that you have a gramophone, you probably want to learn how to use it. Since we don't have a lot of time left in this presentation, we just want to give you an overview of how the gramophone works in practice. Okay, so the first thing we want to do in order to be able to use the gramophone is to write a Faust program. And the program we're going to write here is going to be very, very simple. It's just to demonstrate the various features of the gramophone. So let's do it. So the first thing I'm going to do is I'm going to use the sawtooth wave oscillator because we love it. And as any sawtooth wave oscillator, because it's an oscillator, it needs a frequency. And I'm going to declare the frequency of the oscillator in a variable here, and I'm going to call it freq. And freq is going to be controlled by a slider in the generated user interface here in the Faust Web ID. By the way, guys, we're using the Faust Web ID here, which you can find at faustide.gram.fr. It's free, it's great, and you can use it to program the gramophone. Okay, so we were going to use the slider to control the frequency. And the first parameter of the slider is the name of the slider, and I'm going to call it freq, just like the variable to which it is assigned. The default value is going to be 500. The minimum is going to be 50. The maximum is going to be 1000. And we're going to use a precise step of 0.01. Okay. So now we have a sawtooth wave oscillator, and its frequency is controlled by a horizontal slider in the generated interface in the Faust Web ID, which we're not going to use right now because what we want to do is to control the gramophone. Okay. So the next thing I want to do is to be able to turn it on and off. And to do this, I'm going to create a gate variable to which I'm going to assign a button. And the name of this button in the interface is going to be gate. Okay. And all I'm going to do here is to multiply the sawtooth oscillator to gate. Sweet. So now I can turn it on and off, and I can control its frequency, but the sound that it's going to produce is probably going to be a little bit boring. So I'm going to use a cry baby effect, which is literally a wah pedal. Okay, and it has one parameter, and that parameter is wah. You can actually see that if you look at the documentation of the function just by hovering it. And you can see that the wah parameter is the pedal angle from 0 to 1. So here I'm going to create a new variable, which is going to be controlled by a slider. And the name in the interface of the slider is going to be wah. And I'm going to say that the default value for it is 0.5. That's like the middle of the range. The minimum is going to be 0. The maximum is going to be 1. And we're going to have a precise step of 0.01 as for frequency. Great. Okay. So now I can control the timbre of the sound. I can control the pitch of the sound. And I can control the fact that it's on or off. So that's enough for what we want to achieve here. So now if I want to use this program on the gramophone, I still have to connect those user interface elements to the various sensors which are on the gramophone. The motion sensors, the accelerometer, the gyroscope, or the physical controllers, which are on the case of the instrument, like the potentiometer or the button here. Okay. So let's start with the button. The way we do this is by using metadata. And here, all I'm going to say is that switch 1, which corresponds to this guy on the gramophone, is going to be assigned to the gate parameter. So it's not a switch, it's a button. But, you know, we're French, so we do make English mistakes once in a while, you know. And so even though we say switch, we do mean button here. This is not a switch. Well, it depends on how you use it, but it is a button. Okay. Then I want to be able to control the frequency parameter with the potentiometer of the gramophone. So this one, because this potentiometer here is always for the gain. It's always mapped to control the gain, so the volume of the gramophone while you play it. So you can access this one with the metadata. But in practice, you never really do this. So we want to use this potentiometer here. And the way we do this is by saying knob colon, and this is knob number 2 because knob number 1 for gain is here. Okay. And finally, I want to control the wah parameter using the accelerometer. And the accelerometer metadata in Faust is standard. That's not just for the gramophone, that's for everything that has an accelerometer, and it's ACC con. And then you need to configure it. The first value I'm going to put here is going to be 0. That's the axis of the accelerometer. And 0 is for X, 1 is for Y, and 2 is for Z. Then you can map a curve, and I'm going to use curve number 0. I'm not going to explain to you what it does here, but if you're interested, you can just look at the Faust documentation to know more about it. And then those are acceleration parameters, and I'm not going to explain them as well. You know, like if you really want to know what this does, just look at the Faust documentation. I think that's the best way to do this. Okay. So what is gonna be controlled by the x-axis of the accelerometer. The knob is gonna control the frequency, and the button is gonna control the fact that the gramophone is on or off. Sweet. So this is ready. All I have to do now is to go in the export function of the Faust Web IDE, click on platform, and then choose ESP32. And architecture, I'm going to use the Gramophone Flash. Then you just click on compile. And after some time, you should have a gramophone program that should just be produced and that you can download on your gramophone. And I'm going to show you how to do this in this next step. Okay, so after about 15 seconds, you should have a QR code that displays to your screen. And you are now able to download the gramophone program that was just generated by the export function of the Faust online compiler. So you just download it. After you downloaded it on your computer, you can use the Grammar loader, which is this little program here. It's free. You can find it on the Amsterdam Gram website. And it's free to download. It works on the Mac, it works on Windows, it works on Linux. You have different versions. And all it does is that it creates some kind of bridge between the Faust Web IDE and the gramophone. Okay. So in order to do this, you just have to select. Okay, of course it's in French, you know, like, but you just have to get used to that kind of stuff, you know. Like eventually we're gonna make an English version, but there are so few things to know about this program because it's so simple that for now, French is gonna be the rule. Okay, so here I'm just gonna choose the file that was downloaded on my computer. It's binary.zip, and binary.zip landed on my computer in my downloads folder. And I'm just gonna select it and I'm gonna open it, and then the programming of the gramophone will start happening. This operation will take about 20 seconds. So I'm probably going to see you after that. And eventually, once it's done, you will get a message in the Gramo loader application that will tell you that the programming of the gramophone was successful operation. So let's wait for it. Okay, it just happened. So now we're actually ready to play with the gramophone. You just put it on your hand. By the way, I don't know if you saw that, but the strap is slightly lower on one side than the other. It points towards the ground, you know, so that's where you should put your hand. Don't hold it like this. You have to hold it like this, okay? And eventually, if things actually worked the way that was planned, if I press the button here, I should hear a sound. And it makes a sound, so we're actually happy. So audio is being triggered by the button. I can control the frequency with the knob here. Nice. And I can control the gain with the gain button that I just have over here. And I can control the wah parameter using the accelerometer. Nice. So that's pretty much everything you need to know about the gramophone. One feature that we didn't see yet, you know, is the fact that you can switch between different Faust programs installed on the gramophone using the encoder here. I'm not going to show this feature for now because we don't really have time for it. Finally, one thing you need to know is about this little switch that you have here. This switch allows you to turn the gramophone on in battery mode. So if the switch is at the center position, it's a neutral position, the battery is not connected to the gramophone. So in that case, if you unplug the cable, you will lose sound. Because now the battery is not connected anymore to the gramophone. On the other hand, if you want to connect the battery to the gramophone, you have to go from central position. Once again, there are three positions: left, center, and right. At least from my perspective, it's probably different from yours. So here, if you push it towards the knob next to it, it goes in battery mode. And now you should be able to play the gramophone with the battery. Okay, and finally, the other position with the switch allows you to force the fact that the gramophone is being programmed, because sometimes it can be stuck. All these informations are better documented on the Amsterdam website, so I just recommend you to have a look at it. Okay, so one last thing to conclude this little tutorial. Once the connection is established between the Faust IDE and the Grammel loader through binary.zip, you don't have to select it again afterwards. So it means that all you have to do if you make some changes to the Faust program here is to click on the export button. And just clicking on the export button will produce the gramophone program and will also install it on the gramophone connected to your computer. So you don't have to select the program once again. That's it, folks. If you have any questions, feel free to send them to me by email. I hope you enjoyed this presentation. Okay. There we go. Sorry, it's kind of a complex setup here. So yeah. Yeah, so I will take questions if you have any. I think I replied to most of the questions that were asked in the chat. But yeah, if you have some live questions, feel free to ask them.
Maybe I have two questions, Romain. What about the price of building a gramophone?
It's a good question. So if you just get the parts and if you have the case 3D printed somewhere else, so if you don't have a 3D printer, like the total price is about 110, 120 euros or something like that. But if you have a 3D printer and you print the case at home, of course it will be even cheaper than that. You know, like, so it will be more like 80, 90, maybe like, yeah, actually 70 or 80 euros or something like this. So yeah.
Can you also explain the difference between the Faust IDE in normal mode and the Faust IDE in Amsterdam Gram mode or gramophone mode?
Yeah, it's a good question. So basically, in Amsterdam Gram mode, the IDE is much simpler than in the regular mode. So many of the features are hidden, so that students who are like, once again, middle school students don't change parameters, which might completely screw up the setup of the Faust IDE and don't have any sound coming out of their computer. So yeah, the whole idea is to prevent students from doing something stupid, basically. So yeah, it's the same, but with less features.
Are there any questions from the audience?
Yeah, I'm sorry if this was a little bit dry, but you know, like, I mean, this was supposed to be a workshop where people actually make something, you know, like, and of course, this is not something that you guys could have done in that case, you know, or we could have better prepared things, you know, and ask people to pre-order parts to build their own gramophone at home, you know, like, but yeah, so at least we hope that this will be useful to people who actually want to make the gramophone later, you know, but yeah, I'm sorry if you know, like, all these technical details are not so interesting potentially, you know, in that context, you know, like, but that's what online workshops on hardware are, I guess. So yeah.
Okay. Are there any questions?
Is the Gramophone more compatible with other ESP32 audio boards? Well, not really, because there's well, if you want to make a gramophone which has exactly the shape of the one that we have here, with the STL files that are provided on the Amsterdam websites, the form factor of the board is very very important. And so only that specific board will properly fit in the gramophone. So of course, like, I mean, you could get another board, and because it's an ESP32, you can program ESP32 with FAUS pretty easily. Like that part doesn't really change. But you could adapt the STL files of the gramophone case so that they fit with another board. But if you want to use another board, you'll have to change the files of the case of the gramophone, probably. So yeah. I saw there were other questions in the chat, but I don't see them here. Maybe Jan, you can moderate the questions in the chat. Okay, no, I can see them now. So
okay.
How are the TTGO built-in codecs WRT SNR? Is it advised to use other codecs for performance applications? Well, that is a good question. So the codec on the TTGO T audio board is the same as the one on the iPhone. So it's actually relatively good quality codec, and so the sound quality of that codec is actually pretty good, and there are a few weird things on the TTGO T audio board, especially the wiring of power on the codec in relation to Wi-Fi on the ESP32 board is not really done properly. And so there are some features of the board that you can't really activate if you still want to have audio running on the system. But if you just use it for basic applications, the audio codec is actually relatively good quality on the TTGO T audio board. So yeah. Okay, there are many questions. So okay, then could the gramophone be modified to accept audio inputs so it could work as a sound processing unit? That is also a good question. So there is a microphone on the gramophone, so that is an audio input, but I guess that doesn't really answer your question. So the TTGO T audio board, weirdly enough, doesn't have any physical line inputs on it. However, the audio codec on the TTGO T audio board has a stereo line input on it. It's just that it's not wired at all. So if you're very good at soldering, and if you have very good eyes, and if you don't shake too much, you could potentially solder wires directly onto the codec of the TTGO T audio board to retrieve the audio inputs. I think that's the only way to do this. And it's probably hard to do. Well, I mean, it's not so hard, like, from a technical standpoint, but like soldering on an audio codec by hand is pretty intense. But I've done it before, and it works, but it's hard. Okay, so there are more questions. Okay. Okay. There are comments, but I think that's all the questions that were in the chat, right? or maybe I missed some, or okay, cool.
Okay, so thank you very much, Romain. It was very detailed and very. I think that you can really rebuild the gramophone from this video. So it's going to be super useful, especially because we don't have we built some of them for our purposes, and we have more than 100 of them, but yeah, we don't have a unit to fabricate them. So
Yeah, Thomas Hopman made very good comments about this actually in the chat. You know, and the fact that we don't make PCBs for the gramophone yet. We actually made a very like primary version of the gramophone with a PCB, and it's true that in terms of putting it together, it really helps. But I think in our case, and the way it is used and provided to people for in the framework of the Amsterdam project, it was kind of easier to do it the way we did it. But it's true that using PCB would definitely make things easier in terms of assembling the whole thing. So yeah, maybe a future version, but I feel like for now, and also from a pedagogical standpoint, which is also like something that I didn't really talk too much about in the video, but there are actually students who are going to make their own gramophone in some middle schools, you know, and the soldering aspect of things, you know, and wiring things and cutting wires was something that was actually really asked by the teachers. So that's also one of the reasons why we did it like this. But yeah.
I don't know if you saw it, but there is a question by Peter Kim about the availability of all this information.
So whether this video was the first documentation or I may have missed a GitHub repo for the gramophone. Well, everything is on the Amsterdam Git repository, which I posted earlier in the chat. So if you scroll up in the chat. Okay, and they are, but they are deleted in the end. So, okay, let me. The problem is that I have a complicated. Yeah, there we go. Amsterdam making. Okay, so that's yeah. You found the source. You found the source of what's on the Amsterdam website, and it's a markdown file. So in terms of making the gramophone, everything is here for now. You know, because we'll just assume that the video are the instructions. So